Hi, everyone. Okay, it works.
Hello, everyone. We are Alex and Eugene. We build software at Maib, and today we'd like to share with you how Temporal helps deal with the orchestration pain that inevitably arises when you're building complex business processes on top of distributed systems. And there is two of us up here, not because Temporal is so very complicated, but because the problems it solves are heavy enough so that it really takes two of us to carry the weight of the story.
Yeah, that's true. And here's what we'll cover today. We'll start with a real-world example, our loan origination process. After that, we'll see how simple systems gradually turn into chaos as systems grow. After that, I'll look at how orchestration is usually done today and why it hurts. We will show what Temporal brings to the table and what the pains it treats are. And finally, we'll wrap up with a few thoughts and takeaways you can bring back to your own teams.
So to ground the discussion, let's start with an example that feels like home, at least for me and Alex, loan origination. It is a process that seems linear, and every bank in the world knows it by heart. So a client applies for a loan, we assess their credit and limits, we check the existing exposure, we pull in some collateral information, then comes the paperwork, documents to generate, validate, sign, archive, and finally, disbursement. But in reality, this process is one of the most difficult orchestration challenges a bank can deal with, because behind the scenes, there is dozens of systems talking to each other, waiting, failing, and retrying.
Yeah, on paper, this process looks straightforward. Just a few service calls in a sequence, but then reality kicks in. Different product types, missing documents, rejected signatures, and suddenly you've got a forest of ifs branching everywhere.
And a couple of sprints later, you've got a mini orchestration engine that only works when you whisper to it gently and don't deploy on Fridays. We're not here to shame that. We've all done it. We've shipped that. And to be honest, it's not that we're bad engineers. It's just we are trying to solve complex coordination problems with the wrong tools.
Yeah, retrying a failed HTTP call isn't hard anymore. You've got resilience for J, you've got annotations, you've got all the knobs. But orchestration, real orchestration is more than that. It's about sequencing, failure handling, state, time, business decisions. And the most important, keeping it all reliable. And that's the part where it all starts to fall apart. And that's actually what today is about. How to stop duct taping your workflows together and start building systems that can actually handle complexity without becoming a dumpster fire.
Yeah, so everybody ends up solving this their own way. Queues here, cron jobs there, a bunch of database flags, reconstructing state from logs. And soon you realize that the real challenge is not the business logic, it's the orchestration around it. You either focus on building it properly and watch it consume all your capacity, or you stitch it together with glue and hope it holds.
Yeah, and suddenly, your tiny get-it-done function, representing your straightforward process, has 8 ifs, 3 catch blocks, and 2 helper classes called something coordinator.
Yeah, that's true. One of our old services had a class called like this.
I named that class, and I regret everything.
Don't worry, Alex, it happens to the best of us.
I love you too.
And more to come. There is state. You need to keep track of things. You need to remember what's already been done. Did we send that email already? Did we charge the card? Did the client submit the application? so you log it. And when somebody asks, can I see where the process is at right now? You usually say, let me grab the logs and get back to you.
And scheduling. Let's follow up with the user in 2 days. Great. What do you do? Set a cron, use Quartz, send a delayed queue message, or, and this is my favorite one, write a scheduled tasks that check every 10 minutes if a row in DB is ready for action. You all ever done that?
That's perfectly fine. We have to. And suddenly, you realize that when you multiply this across dozens of systems and teams, your architecture diagram qualifies as abstract art.
Yeah, indeed. And it's not that these problems are unsolvable. We solve them all the time. But let's be honest, we solve them badly, repeatedly. And notice something funny. I bet all of us here have already forgot about the loan origination process we started discussion with. And that's about the time developers forget what their business does. And that's what is today about, actually. We are building retries. We build error handlers, state machines, instead of building products. We reinvent orchestration one queue at a time. So we decided maybe someone have already solved it properly.
And thankfully, someone did, the team behind Temporal. The roots of this project go all the way back to early 2000s, where its founders were building reliable systems at Amazon that were handling billions of reliable operations. Later, they evolved their ideas at Uber, where they created a platform for orchestrating everything, from payments to rides and deliveries. And eventually, the project went open source, and this is how Temporal came to life.
Yeah, in other words, the people who kept Amazon and Uber running decided to make reliability everyone's problem to stop solving. And that's really nice. And when we found it, we were skeptical. Workflows as code, no queues, no state management on our side. And it felt too good to be true.
Yeah, indeed. What if your code never failed? Building invincible apps. All these are their slogans that sound a bit cinematic, isn't it? But the more we played with it, the more we realized it's true. It is a platform that takes care of orchestration for you and makes sure every step of your business process runs reliably, even when things fail, crash, or restart.
And how does it actually do that? Let's speak at Temporal's mental model. The systems are built from just two core ideas, the workflows and activities. The workflows define what should happen, the actual business process itself. And activities define how each step is executed, the actual work done by your services. And together, they form a simple, deterministic architecture, the brain and the muscles of your processes.
Exactly. So now to strip away the metaphor, let's lift the lid and look at the wiring. At a high level, Temporal consists of three main parts. Temporal server, which is the durable brain and the backbone of the orchestration. It stores state, tracks history, and makes sure nothing is lost even when workers restart. The workers, this is where your application code runs. They host workflows and activities and execute steps. And finally, the clients, these are the application or services that start workflows, send queries, or query progress. From a deployment perspective, Temporal Server runs independently. It is a persistent application service your application talks to, and it's not part of your delivery pipeline. The workers and the clients, on the other hand, are. These are the pieces that you build, ship, and evolve with every release. And together they form a system that's distributed yet fully reliable.
Yeah, and all this machinery exists for just one reason, so that your entire business process can be expressed as a single simple function. Let's take a look. Here's the example. Instead of manually stitching services together, you just write a function, a workflow function, that describes the steps of your business process. And the cherry on top is that it's just code, which means you can unit test it like any other function. Inside that function, you call activities. These are the things that actually do the work. Call an API, write to a database, perform some computations, whatever actually. So far, sounds like regular code, right? But here is the magic. Temporal persists the state of that function. Every input, every decision, every timer. So when the service crashes, because of course it will, Temporal brings it back exactly where it left off.
And timers. Let's spend a moment on them as well. Timers are purely declarative. You can literally write, like on the last line of the function, workflow.await, 7 days or even 7 years is just your call. And Temporal doesn't keep anything running. No polls, no cron jobs, no fake scheduling hacks. We have used it for things like wait for a computation result for 15 minutes, then escalate. Remind the user to bring the doc in 7 days. Wait for at most 3 hours for a client to submit the application. And the best part of it is while waiting, a workflow doesn't keep anything running. No threads, no busy waiting. Temporal just records the wait in the history and releases every resource. When the time comes, the workflows function exact state is reconstructed as if nothing ever stopped.
Yeah, and that's really nice. Oh, and observability. You get it for free, absolutely. You can query a workflow, see its entire execution history, and if someone asks, where is the loan application for client X stuck, we actually know. In Temporal's UI, we can query for that workflow, see its entire execution history. We can click through each step and see when it ran, how long it took, why it succeeded or failed. And even more, we can replay that workflow from any point in the history with the same data and the same decisions, like a time machine for distributed systems.
Behind that beauty is a single append log file, the entire history of your workflow. You can think of it as a black box flight recorder for your process, and if something goes wrong, you don't just inspect logs. You can actually replay the whole flight. Same inputs, same outputs, same decisions, perfectly deterministic. You can even download that history as a JSON file and play with it locally for additional debugging maybe, and you can even watch the workflow retrace its exact steps exactly as it did in production.
Yeah, and considering all that power, we were lucky enough not to learn it the hard way, because we had already seen what happens when orchestration is treated as an afterthought. This time, we wanted to build on something solid from day one to make reliability part of the design, not a patch later. And we are not saying Temporal is perfect, but for us, it changed the way how we think about orchestration from please don't break to just let's model it clearly. But to really get the most out of it, you have to know when Temporal is in its natural habitat, the kind of problems it was born to solve.
Temporal really shines when your system goes far beyond simple request response, when your process touches multiple services and they are waiting for people or external system inputs for a long period of time, when you can't absolutely afford to lose track of what happened. And most importantly, when you trust your engineers and want the code to be the single source of truth.
Yeah, everything comes with trade-offs. Temporal solves a huge class of problems, but adopting it isn't just flipping a switch. It's not a library you import. It's an architectural choice. So the next logical question is how much it actually takes to bring temporal into your system. What are the costs? Financial or maybe operational?
The good news is temporal doesn't force you into a big bang adoption. You can start as small as running it in memory on your local machine, which is perfect for prototyping or experimenting. Later, if you get the taste of it, you can spin up a self-hosted cluster for full control. And when you're tired of managing it and earned enough money, maybe, then you can move to a managed cloud setup. Single region, multi-region, or even multi-cloud setups for really big enterprises. Luckily, every transition here is just an operational choice, not a full redesign of the system. The idea is pretty simple. Temporal grows with you, technically, operationally, and financially.
And that's really the beauty of it. You don't have to commit to the full-scale replatforming. You can grow in temporal as your systems and processes grow in complexity. But beyond architecture and adoption, there is something deeper here. It's about how we build systems in general, how much time we spend on wiring things together instead of solving actual business problems. And that's what we want to leave you with.
Every team eventually faces orchestration, whether they plan for it or not. The question is whether you handle it with glue, flags, and cron jobs, or with a system designed for it. And most importantly, battle-tested at the scale of Fortune 500 companies. Temporal doesn't make your business simpler. It just makes your chaos manageable and lets you focus on what's really important. The flow, the product, the customer.
Yeah, that's true. So, guys, if you are building systems where the state is reconstructed from flags and logs, where coordination is spread across services, where orchestration means a diagram that nobody fully understands, then maybe, just maybe, you are not building features. You are building glue. But you don't have to. Temporal gives you an actual model for workflows with no tricks and no workarounds. So we will say it one last time. Fragility is dead. Long live temporal.
Thank you. We'll be around if you want to dive deeper or see some examples of the code. Thank you.